Hello, welcome to another class with Ming. Today we talk about logic part 4. And here, today's focus is on some terminology. First of all, that is inverse, which we have been introduced before. The inverse of P is just written as this one, with this symbol here, like 7, with a very long head, 7P, right? So for example, P x is equal to 1, the inverse of that would be x is not equal to 1. 7x equal to 7, the inverse of that is 7x is not equal to 7, right? If you have a statement saying that x is an even number, then the inverse of that will be x is not an even number. So x can be an odd number or x can be a 0. And then the another one is called converse. Converse of an implication. P implies Q is Q implies P. Basically, you put the result in front and the condition at the back. You reverse the order. Q implies P. This is called converse. Converse. Remember, converse, inverse, they are not the same thing. Inverse is just the opposite. Converse is the condition goes to the back and the result goes to the front. So Q implies P. So let's look at the example, right? P is equal to x equal to 1, Q equal to 7, x equal to 7. Write out the converse of P implies Q. So that will be Q implies P, and that will be, right, if 7x equal to 7, that's my Q, then P is equal to, then x is equal to 1. So that's my converse. That is Q implies P. Q implies P. Okay? And then example number 2. Example number 2 say Sonam is in Karizawa. Sonam Q. Sonam is in Japan. We've seen this before, right? The implication is that if Sonam is in Karizawa, then Sonam is in Japan. The converse to that will be if Sonam is in Japan, that is, put the result first, then Sonam is in Karizawa. So this is Q implies P, right? Now let's go back and have a look, right? Is the implication here true? If x equal to 1, then 7x equal to 7. Is that true? Yep. The implication here is true. Is the converse true? Actually, in this case, the converse is also true. If you start with 7x equal to 7, simplifying this will give me x equal to 1. So the converse here is true. Having said so, the converse doesn't always have to be true. In this case, Q implies P is true. Only in this case. It's not true in general. Now let's look at this example number 2. Now, if Sonam is in Japan, then Sonam is in Karizawa. Is that a true statement? Well, you know that is not true, right? Because if Sonam is in Japan, she could be in Tokyo. Tokyo is not Karizawa. If Sonam is in Japan, she could be in Okinawa. Okinawa is not Karizawa. So in this particular case, right, Q implies P is not true. Right? Actually, in general, the converse is not true. The converse is not true in general. So this is actually a special case. In fact, remember what we said before? If P implies Q is true and Q implies P is true, what do we call the relationship between P and Q? Very good. Equivalent. Right? Since these two is true, example number 1 should really be written as P is equivalent to Q. P is the necessary and sufficient condition for Q. Alright, then we look at another concept. This is called contrapositive. Of P implies Q is not Q implies not P. Not Q implies not P, or the inverse of Q implies the inverse of P. So that's contrapositive. Converse is Q implies P. Basically, contrapositive, you can think of it as the inverse. This is the inverse of converse. If you written it that way, it looks really weird. That is, Q implies P with the not, the inverse sign in front. So this is the equivalence of not Q implies not P. Right? Contrapositive. So let's see. Let's look at an example. X squared is odd. That's P. X is odd. That's Q. The contrapositive will be contrapositive is not Q implies not P, which is if X is not odd, then X squared is not odd. So that's my contrapositive. X is not odd, then X squared is not odd. Now, so today we look at inverse. That is just not statement. It's the opposite. Converse, you put the result first, implies the condition. So Q implies P. If you have P, converse of P implies Q is Q implies P. The converse of a particular implication is not always true. In fact, it is usually not true. If the converse is true and the implication is true, then this is actually called the equivalent. The contrapositive is not Q implies not P. Right? Not Q implies not P, which is also called the inverse of the converse. The inverse of the converse. Not Q implies not P. Alright. As a summary, you may want to draw a chart linking implication with inverse, converse, and contrapositive. Thank you.